Welcome to the deep dive. Today we're digging into a truly extraordinary stack of source material, taking what might be the ultimate cosmic temperature check.
That's a good way to put it.
For years now, we've all been getting used to this idea that our solar system, it gets visitors from beyond. It started back in 2017, I think. The whole astronomical world was just completely captivated by the discovery of Oumuamua.
Oh, absolutely. It was the first one, the first confirmed interstellar object.
And it was essentially a silent, tumbling rock.
Ah,
But it had that strange acceleration, didn't it? The one that defied a simple gravitational explanation.
it did. It was an anomaly, for sure. Then fast forward 2 years, 2019, and we get to Borisov.
Right, and Borisov was much more normal.
Exactly. It looked and acted almost exactly like a standard comet. The only weird thing about it was that it originated from a completely different star system.
So those first two objects, they were remarkable, yeah, but they were astrophysical curiosities.
They were. They confirmed what theory had predicted for a long time, which is that our solar system isn't some sealed-off bubble. It's constantly being bombarded by the natural passive debris of other star systems.
Just space flotsam, passing through, silent, predictable, even if Oumuamua was a little unusual.
Yes, exactly. But the object that's commanding all the attention today, the reason we're doing this deep dive, that's the third confirmed visitor.
3I Atlas. Officially, it's C2025N1.
And based on the comprehensive analyses we've both been reviewing, ATLS is in a category. Well, it's entirely by itself.
It just refuses to fit the expected parameters, not just for comets, but for orbital mechanics in general.
Right. It is behaving less like a passive chunk of ice and much, much more like an actor that is operating with purpose inside our system.
And the difference is, it's striking. The stakes feel much higher.
They are, because we're not talking about just one or two little discrepancies. We're looking at a whole chain of independent anomalies that, when you put them together, they force the analysts into this critical dilemma.
And what's that dilemma?
Well, you're left trying to reconcile two vastly different possibilities. On the one hand, possibility one, this is a natural phenomenon, but one so statistically improbable and physically contradictory that it borders on being impossible.
Okay. And possibility two.
Possibility two is that we are observing the unmistakable, though very cleverly veiled signature of intelligent technology.
And this is what really lends this deep dive. It's urgency, isn't it? It's the formal conclusion that the analysts have drawn from all of this cumulative evidence. They're not backing away from a high-stakes assessment here.
And not at all. They've crunched the numbers. They've looked at the combined improbability of all these anomalies happening together by chance.
And they've put a number on it.
They have. They estimate the probability of an artificial origin for ATLAs is somewhere between 20 and 25%.
20 to 25%.
That is the critical number, and it's so important for people to understand why a number like that is so alarming.
It's not background noise.
It is so far beyond background noise. It's not wishful thinking. It's not some fringe theory. In the world of scientific risk assessment, that range, it's considered an alarm-stand.
An alarm state.
An alarm state. It's basically an explicit instruction to the entire scientific and intelligence community saying, stop treating this as a natural certainty. You need to start investigating the technological hypothesis with serious resources because the evidence is now scientifically compelling.
So our mission today is to unpack exactly that. We're going to trace this entire chain of anomalies, from its nearly impossible trajectory to the physical signs of it maneuvering, all the way down to the strategic logic of its silence.
All the pieces that push that likelihood of artificiality up to that dangerous and frankly fascinating 25% threshold.
And we have to start with the single most statistically unlikely piece of the entire puzzle, its flight path. So when we talk about our solar system, we have to talk about the ecliptic. For anyone who isn't familiar, can you just quickly break that down?
Of course. The ecliptic is essentially the plane of space that all 8 of our major planets orbit on, and most of the smaller bodies too. It's basically flat.
Like a dinner plate.
An even better analogy from the source material is to think of our solar system not as a big sphere, but as a vast, incredibly thin vinyl record spinning in an otherwise empty auditorium.
Okay, I like that.
All the major mass, Mercury, Earth, Jupiter, all of them is basically glued to that record. That record is the ecliptic plane.
And if you go above or below that record?
You're in a very low-density region of space. It's called the isotropic volume. Isotropic just means it's the same in all directions.
So with that in mind, if you are a random piece of debris, say a comet that got ejected from a distant star or some dark tumbling rock,
Hmm.
where should you come from?
You should come from anywhere,
Yeah.
absolutely anywhere. The galactic environment where these objects come from is isotropic, so they should randomly strike our system from any direction.
High angles, low angles diagonally.
Hmm. Exactly. Statistically, the vast, vast majority of interstellar debris should not preferentially hit that one incredibly thin, flat vinyl record. It makes no sense.
So if something does hit the plane,
It's most likely an accident, a coincidence. It just happens to cross it on its way through, and it does so very quickly.
like Oumuamua did,
Precisely. Oumuamua came in from a very steep angle, which is exactly what you would expect from random cosmic junk. It just sliced through the plane and was gone.
which brings us to ATLAs and the most powerful geometric anomaly about it.
It's not crossing the ecliptic.
No.
It is moving with almost surgical precision exactly within that ecliptic plane. It's essentially surfing the very plane defined by our inner planets.
This is where the statistics just go from mind-boggling to,
Yeah.
well, to almost absurd.
They really do. The sources quantify this. They give us the exact probability.
And what is it?
The statistical probability for a random interstellar object to hit this specific orbital plane with such a low inclination is just 0.2%.
0.2.
Yes. It is literally one chance in 500. The analysts note we are operating in the Promillebereich, the per mil range. It's a term you just don't see in astrophysics very often.
So if you threw a dart blindfolded from a distant nebula,
The chances of it hitting that specific thin plane with the precise angle you'd need to actually stay in it, it's mathematically so unlikely that the sources explicitly describe it as a statistical impossibility.
nature just doesn't do that.
Random nature simply doesn't favor such precise geometry. It's a statistical red flag of the highest order.
Okay, that makes the case for statistical impossibility very, very clear. So now, let's flip the lens. Let's assume for a moment this isn't random nature.
Let's look at it strategically.
Yes, why would a highly sophisticated reconnaissance mission choose this impossible path?
Because that path is what transforms a statistical improbability into a strategic certainty. It is the single most optimal choice for what analysts are calling a grand tour, a long-term systemic mapping mission.
Explain the geometry of that.
Yeah. Well, think about it. If you fly perpendicular to the ecliptic, like Oumuamua, you just get these fleeting snapshots. You cross a planet's orbit at one single point, maybe you get a quick glimpse of Earth.
And then you're gone?
You're gone instantly, your path takes you high above the system, and you're back out into deep space. The observation window is tiny.
But if you fly within the plane,
You can spend months observing. By flying within the ecliptic, you can sequentially pass by and observe multiple high-value targets over a very extended period. You can synchronize your observation windows.
so you can, as the sources say, swim in the system rather than just briefly passing through it.
Precisely. The trajectory chosen by ATLS is not accidental. From a strategic point of view, it is maximally efficient for gathering information.
And the sources get specific about this, don't they?
They do. They specify the sequential flybys that this exact path allows. Jupiter, then Mars, and then Venus. ATLS is positioned perfectly to have sustained, clear lines of sight to all of them.
So it's behaving less like random debris.
And much more like a strategically positioned observer that is systematically mapping the major bodies in our system, testing the gravitational environment, and just maximizing its data collection time.
The trajectory suggests intent, not coincidence.
It's a powerful argument. The first foundational anomaly is that the object is exactly where it strategically should be for a recon mission, even though statistically it has absolutely no business being there.
That is a massive opening argument for the technological hypothesis.
Okay.
So from the geometry of space, we now have to move to the physics of motion.
Right. And this is where the skeptics usually make their stand.
And on the surface, it sounds pretty reasonable. They say, look, ATLAs has a tail, it has a coma, that means it's sublimating ice, so it must be a natural comet, a dirty snowball, end of discussion.
It's an appealingly simple argument, but it completely ignores the fundamental requirement of Newton's third law when you're talking about space travel.
Action equals reaction.
Action equals reaction. The presence of a tail does not automatically mean ice. Any change in momentum, any kind of maneuvering in the vacuum of space, requires the expulsion of propellant mass.
Stutz mass, as the sources call it.
Exactly, and that mass expulsion creates a visible gas cloud.
So let me get this straight. If I'm on Earth, looking through a powerful telescope from hundreds of millions of kilometers away, I cannot tell the difference between ice vaporizing off a comet and a high-velocity, high-temperature plasma exhaust plume from an engine.
From 1.8 astronomical units away. No! In terms of their gross morphology, they are functionally indistinguishable. Both just look like a hazy cloud reflecting sunlight.
But there must be something else, the real evidence that completely undermines this dirty snowball idea.
There is, and it's the observation that confirms active maneuvering. It's the existence of the anti-tail.
Okay, let's break that down. A normal cometary tail,
Yeah.
what does it do?
If you have a comet moving through the solar system, the solar radiation pressure, that continuous flow of charged particles from the sun, the solar wind, it physically forces the vaporized material away from the sun.
So the tail always points radially outward, away from the sun, no matter which way the comet is moving.
That is standard textbook physics. ATLS, however, violates standard physics.
What does it do?
The paradox is that ATLS exhibits a distinct structured jet of material that, for a time, points toward the sun.
Toward the sun.
It is actively, energetically pushing against the solar wind and against the sun's gravitational field.
So it's pushing toward the massive object it is approaching. That sounds completely counterintuitive.
Unless you think about it in the context of propulsion.
Okay, so in the unambiguous language of space travel, what does that signature mean?
It is the physical, undeniable signature of a massive braking maneuver, what engineers would call a retrograde burn.
A retrograde burn.
Think about it. If you're an object traveling inward, approaching the sun, which ATLAS is, and you want to slow down or stabilize your velocity, or just precisely adjust your orbital parameters.
Maybe to, align your sensors on a distant target like Earth?
Exactly. To do any of that, you must fire your main engine in the direction of your flight. And since the direction of flight is toward the sun, the exhaust plume necessarily has to point toward the sun.
And we're not talking about a tiny puff of gas here, are we?
Not at all. Given the estimated mass of ATLAS, even if it's not Manhattan-sized, it is certainly a substantial object. A maneuver massive enough to create a visually detectable anti-tail implies an extraordinary amount of energy.
What kind of energy levels are we talking about?
The sources suggest it implies a continuous powered thrust operating in the gigawatt range.
A gigawatt?
Yes. For comparison, comets do experience very minor non-gravitational accelerations from outgassing, but they are erratic, they're subtle. This anti-tail, however, suggests a sustained, deliberate application of force to drastically alter its momentum relative to the sun.
This isn't engine firing, not just some ice cracking in the sun.
The presence of the anti-tail is the smoking gun of active course correction and propulsion. It's a game changer.
So the behavior points to an engine. Now we can look at the chemical residue of that propulsion. If we use spectroscopy to analyze the light coming off that coma and tail, what's the chemical fingerprint?
We see something completely, utterly exotic for a comet.
How so?
The coma shines with this unusually intense blue color, and the spectroscopic data is overwhelmingly dominated by lines that correspond to ionized carbon monoxide, CO+, and CN.
Yeah.
But the most critical part, the thing that really breaks the comet model, is that the spectra show a conspicuous poverty of water. There's very little sign of it.
And that's the definitive challenge, isn't it? Because comets are, by their very definition, all about water.
They are defined by water vaporization, specifically water ice and what are called hydroxyl radicals, OH. If an object isn't spitting out significant amounts of water, it is not a comet in the classical sense.
The sources call this combination high CO and cyan, but low water exotic and chemically unconstrained.
Right. It doesn't fit our models for natural objects. But this is where the technological interpretation provides a clean, thermodynamically elegant answer.
Which is?
That precise chemical signature, the high carbon monoxide, the cyan, that distinct blue glow, is entirely consistent with the expected exhaust plume of a highly efficient nuclear thermal propulsion drive, an NTR.
Okay, walk us through the engineering logic of that. Why would an advanced engine use carbon monoxide? Why not just use hydrogen or water, like our concepts?
It comes down to something we'll talk more about later, the economy of stars. It's all about mass efficiency. An advanced interstellar civilization has to minimize the mass it carries across these vast distances.
And water is heavy.
Water is heavy. And while it's a decent propellant, it requires massive storage tanks. It's also generally less available in deep space environments than carbon-based molecules are.
But carbon monoxide, CO, is everywhere.
It's universally abundant. It's a major component of interstellar molecular clouds. It's relatively easy to manufacture or just collect in almost any star system. And crucially, it can be heated very, very efficiently.
And how does the NTR engine use it?
The engine works by routing this readily available propellant, the CO, through a nuclear reactor core operating in the gigawatt range. That reactor heats the gas to immense temperatures, thousands of degrees Celsius, and then expels it out the back at an extremely high velocity.
And the blue light is the giveaway.
The blue light is the visual evidence of that high energy expulsion, the high concentration of ionized carbon monoxide, the CO plus and the cyan, CN, that suggests an extreme energy transfer is happening. We are literally observing the high energy plasma exhaust itself, not the gentle evaporation of ancient ice.
And that intense blue color is a signature of this high-energy process.
It's a signature of high-energy ionization. So the chemical fingerprint of ATLAs is consistent with a powerful, high-performance propulsion system built for interstellar transit, not a fragile chunk of ice.
So, to put it all together, the anti-tail tells us it's maneuvering,
Yeah.
and the blue glow tells us what kind of engine is doing the maneuvering.
Exactly. The physics and the chemistry both point away from nature and toward technology.
Okay, so let's just quickly summarize where we are. We have a flight path that is strategically ideal but statistically impossible. That was part one.
Right.
Then we have a physical signature, the anti-tail and the blue chemical fingerprint, proving massive, deliberate maneuvering, likely driven by an advanced engine. That was part two. So now we have to turn to the strategic logic of how this object is operating, and this focuses on its distance from us.
Yes. Its closest approach, its perigee, is set to occur around December 19th, 2025. But, and this is the key, it remains incredibly far away.
How far?
About 1.8 astronomical units. And AU is the distance from the Earth to the Sun, so we're talking about roughly 270 to 300 million kilometers away.
Wow, this is really far.
And this distance is the third major indicator of intelligent design.
How can being far away be an indicator?
Well, while it's certainly disappointing for anyone hoping to see it with a backyard telescope, it's far too distant for that. This distance is very precisely calculated. It's what you'd call the tactical sweet spot.
It's the definition of standoff reconnaissance.
Exactly. This range creates an extreme, and I would say purposeful, asymmetry in the intelligence-gathering battle space.
Let's explore that asymmetry. Let's start with our perspective here on Earth. If we take our most advanced instruments, something like the James Webb Space Telescope or our biggest ground-based arrays, and we point them at ATLAs from 1.8 AU away, what do we actually see?
We see what the sources call an unsharp point, a fuzzy dot.
That's it, with the Webb.
That's it. It's about the physics of angular resolution. From that vast distance, even the JWST, which is designed to see the first galaxies, cannot resolve physical features on an object of this presumed size.
So we can't see, like, an antenna dish or a hatch or a maneuvering thruster.
To get a clear image of something like that, the feature itself would have to be hundreds of meters across. Because of the distance, our best instruments simply lack the capacity to physically resolve any critical details. It's a physical limitation for us.
And the object itself, with its plume, whether it's from ice or an engine, that helps camouflage it too.
It's the perfect camouflage. The coma, that massive cloud of material surrounding the object, serves to hide its structure behind this vast blue, hazy veil. It makes it appear entirely consistent with a large, distant comet.
So it looks natural, but the distance prevents us from ever getting close enough to confirm that.
Precisely. It allows the object to remain functionally hidden behind the very natural phenomenon it appears to be mimicking.
Okay, that's our side of the asymmetry. Now let's flip the perspective. This is the part that's far more chilling. What does Earth look like to a highly advanced civilization observing us from that same 1.8 AU?
For them, Earth is an open book. Yeah. Absolutely. Our distance limitation is completely irrelevant to them.
What kind of things could they see?
Well, for starters, they can perform atmospheric analysis with surgical precision. Our atmosphere is highly, highly anomalous compared to the rest of the solar system.
It's rich in oxygen, methane.
And the unmistakable artificial signature of our civilization. CFCs, nitrous oxides, industrial pollution. They could analyze the chemical composition of our biosphere instantly and confirm beyond any doubt the presence of a vast technological civilization.
So they don't just see a planet, they see our operational status.
That's a perfect way to put it. They can count our city lights on the night side of the planet, which allows them to quantify our energy distribution and our population centers.
They can listen.
And crucially, they can listen. From 1.8 AU, they can collect, demodulate, and analyze the entire spectrum of our unencrypted radio communications, our radar emissions, our digital transmissions.
So the distance is perfectly calculated.
It is. It's far enough away to avoid physical identification by our highest resolution telescopes or radar. But it is close enough for complete high-fidelity data collection on our civilization's technological and biological status.
This leads us directly to the strategic implication of the object's pervasive silence. If this were some benign, peaceful probe looking to make contact, wouldn't we expect a signal? Hello?
You would think so. A greeting, an acknowledgement of some kind. But ATLA is completely, totally silent.
And this is where the strategic analysis brings in this concept of the dark forest theory.
Yes, which was popularized by the author Cixin Liu, and that theory posits that advanced civilizations across the galaxy operate in an environment of, well, of existential paranoia.
Because the distances are so vast, you can never really know another civilization's true intentions.
Exactly. So what's the safest course of action?
Stealth.
Stealth. Advanced civilizations prioritize stealth because open contact, revealing your location, your technological capacity, is seen as an uncalculatable existential risk. The moment you reveal yourself, you instantly become a potential target in a hostile, unforgiving cosmic environment.
So therefore, the object's persistent silence is not interpreted as proof that it's natural.
Quite the opposite. The analysts view it as evidence of the highest strategic competence and discretion.
It's the action of a rational observer with intentions, one that understands the rules of the larger galactic game.
Absolutely. The chosen distance and the absolute silence are highly rational, self-protective actions for an advanced, discrete observation mission. The very lack of a signal is, in itself, a massive data point that indicates strategic capability and, perhaps, hostile intent.
So this brings us to the operational aspect of the mission.
Yeah.
And we have to start with a big problem, a thermodynamic problem.
Right.
If ATLAs is what some of these analysts are speculating, a truly massive object, maybe that Manhattan-size idea weighing billions of tons, then for it to significantly change its course, to perform detailed local maneuvers near Earth, that would require just astronomical amounts of energy.
That is the paradox of stealth versus maneuverability. They're at odds with each other. To apply the necessary thrust to redirect a multi-billion-ton object from its current flyby trajectory to a tight intercept course with Earth, you would need to expend the energy equivalent of several large nuclear power plants operating continuously for days on end.
And that kind of energy expulsion would result in a brilliant, devastating energy flash.
A supernova in miniature. And that light show would instantly compromise its stealth. It would confirm its artificial nature to everyone on the planet, and it would spark immediate panic and reaction.
The mission would fail strategically because you've alerted the target.
Precisely. You've revealed the true nature of the intrusion.
So the object's continued behavior, its decision to maintain this distant, predictable flyby course, that's not a sign that the mission failed or that it gave up.
No, it's evidence of a much more sophisticated strategy. This is what the sources are calling the modular deployment strategy, or the Matryoshka strategy.
Like the Russian nesting dolls.
Exactly like the nesting dolls. This is the core tactical hypothesis. ATLS itself functions as the Traeger ship.
The carrier or the mothership.
Right. It's a massive, highly shielded vessel that's designed specifically for the rigors of interstellar travel. Its primary mission is to maintain its course, execute that standoff reconnaissance we just talked about, and preserve its stealth parameters while it delivers the operational units.
And these operational units, the smaller dolls, they're deployed modularly, shielded from our observation at first.
Yes, they're launched into the system under the protection of that signature cometary tail, that plume from the NTR drive we discussed.
So the propulsion system is dual purpose.
It is. It provides the thrust for that retrograde burn to adjust its orbit, and at the same time, its large volume of plasma exhaust temporarily shields the launch of these smaller units from our view.
So what are these units? What are the layers of the doll?
The sources detail a multi-layered deployment. The first layer, just under the mothership, are the sub-motherships.
The sub-motherships.
Intermediate units. They're estimated to still be significant in size, maybe 100 to 200 meters, and they carry the ultimate payload. But critically, these intermediate units would be launched cold.
What does a cold launch mean in this context?
It means they are expelled without a massive detectable thermal signature. Instead of firing your own big engines, they are likely accelerated electromagnetically.
Like a railgun.
A massive coil gun or railgun that's integrated into the mothership's structure. This gives them the mothership's initial velocity vector, so they only need minimal, subtle energy correction later on to precisely vector toward Earth. Because they don't produce a brilliant heat flash, they maintain stealth.
And how would we even detect these large, silent subships? They're still pretty big.
That's the point. We might not. They are hypothesized to use highly effective radar-absorbing surfaces, things that might resemble vantablack or other structurally analogous materials that would make them nearly invisible to our conventional radar systems at extreme range.
So they're dark, they're quiet, and they're thermally minimal.
The perfect stealth delivery system.
And those sub-motherships, they're the delivery system for the final element.
Yeah.
The Scouts.
Correct. The Scouts are the final innermost gull. They are the highly maneuverable operational components, estimated at only 5 to 15 meters in size. These are the units that are optimized for atmospheric entry, for high-G maneuverability, and for close-range surveillance inside our atmosphere.
And the analysts explicitly connect this size and this maneuverability profile to existing known phenomena, don't they?
They do. The sources directly compare these operational scouts to the objects described in well-known UAP reports, unidentified aerial phenomenon reports.
The tic-tac objects.
Specifically the tic-tac objects that were observed by U.S. Navy pilots. The descriptions match. Small, highly maneuverable, lacking any visible means of propulsion, and operating with an understanding of physics far beyond our current capabilities.
So when you put this all together, the entire ATLA's mission is described as a classic magic trick.
It is pure Ablenkung distraction, a misdirection. The entire world, all the telescopes, the media, the public, we are all watching the large, spectacular blue primary object that is moving predictably across the sky.
We watch it execute its flyby, we see it disappear back into deep space, and we think the event is over.
But the actual operational component, a swarm of small, silent, dark probes, has already been deployed and is on an unobserved intercept course toward Earth. The mothership goes dark, its mission complete, while the real work of mapping and surveillance begins, completely unnoticed by those of us who are still looking out toward deep space.
We've established the strategy, the how. We've established the technology that brings ATLS to our system. But now we have to ask the most profound question of all. Why?
Right.
I mean, interstellar travel has to be the ultimate engineering challenge. The sheer scale of the energy investment required for a mission of this magnitude. The sources say it would demand the resources of a civilization rated as Kardashev Type 1, maybe even Type 2.
And that level of energy consumption where you're potentially harnessing the total energy output of an entire planet or even its star, it means the objective cannot be frivolous. It can't just be academic curiosity.
In the economy of stars, every project must have a massive return on investment.
It has to. And they are not coming here for common elements like iron or silicon. Those are abundant everywhere in the galaxy. They are here for unique, high-value planetary attributes that they can't get just anywhere.
Okay, so let's analyze the 3 suggested strategic motives that the analysts have derived from what we can observe about the mission, its stealth, its trajectory, its capabilities. The first one is colonialism, the real estate motive.
This motive hinges on just how cosmically rare our planet is. The universe is vast, but habitable worlds like Earth are incredibly scarce.
It's prime real estate.
It's the definition of prime galactic property. It has vast quantities of liquid water on the surface, it has a protective, oxygen-rich atmosphere, and it has a powerful magnetic field that shields it from deadly cosmic radiation.
So if this mission is an Arche, a long-duration generational ship, or maybe an advanced probe that's searching for a new home world, the motivation is just purely territorial acquisition.
And in that scenario, where does that place humanity?
We're in the way.
We are considered besetzer occupiers, or maybe indigenous people, standing directly in the way of a highly strategic, high-value goal. The analysis suggests a civilization with the capacity for interstellar travel would view acquiring a ready-made, habitable planet as a strategic necessity, regardless of its current tenets.
Our existence is simply an obstacle to them acquiring a prime piece of galactic real estate.
That's a sobering thought.
It is. Okay, the second motive. This one deals with biology. They term it bioprospecting.
This motive recognizes that the Earth's complex, interconnected biosphere is arguably its single most unique and valuable asset.
How so?
4 billion years of evolution has created DNA, proteins, enzymes, and molecular structures that represent an astonishingly effective self-replicating chemical factory. The complexity here is just staggering. It would be incredibly difficult, maybe even impossible, to replicate artificially in a lab.
So the mission isn't necessarily focused on conflict, but on
Harvesting.
Exactly. The goal would be to harvest Earth's biology, our genetic and molecular complexity.
For what purpose? Maybe to repair their own degraded biology or to enhance their capabilities, or simply to catalog the diversity of life as a resource. In this view, we are not seen as an enemy. We're seen as an incredibly complex, useful resource to be exploited.
Like a massive natural chemical factory that just happens to yield unique compounds.
Right, and the scouts would be tasked with collecting biological samples, mapping ecosystems, and maybe even developing selective extraction methods.
Okay. Now let's move to the third, and I have to say perhaps the most strategically terrifying motive. Preventative Unterdrückung. Preemptive suppression.
This one is rooted very deeply in that dark forest logic we talked about, and also the concept of the Great Filter.
It's pure cosmic game theory.
It is. The Great Filter idea posits that there is some event or challenge that prevents almost all civilizations from achieving interstellar capability. It's why the galaxy seems so quiet.
So if ATLAS represents a Type I or Type II civilization that has passed the filter,
They would logically view all emerging technological civilizations like ours as potential future threats.
and humanity is getting close to some critical thresholds.
We are. The rapid development of advanced artificial intelligence, what some call super AI, are pushed towards self-replicating industrial infrastructure. Even our early rudimentary efforts toward interstellar travel. All of this makes us a rising star in the cosmic threat landscape.
So in this scenario, ATLAS is not a curious tourist.
It's an automated patrol.
A patrol?
An automated patrol designed to identify, monitor, and potentially neutralize emerging civilizations before they can achieve the capacity to pose a galactic threat.
And if that's the motive, the deployed scouts have a very clear objective.
A very clear and chilling objective. They wouldn't be looking for genetic material. They would be mapping our critical infrastructure,
Our satellites, our energy grids.
our communication networks, our military response capabilities. They would be gathering all the data required to effectively neutralize us with minimal effort and minimal risk to themselves. A potential, highly strategic preemptive strike.
This analysis just fundamentally shifts the entire perception of the ATLAS event, doesn't it? We're moving from this philosophical question, are we alone, to a much more urgent, tactical question.
Are we a threat, and what are they planning to do about it?
And in that context, the entire strategy makes perfect sense. The calculated stealth, the perfect standoff distance, the Matryoshka deployment.
It's the only rational course of action for a civilization that's executing a discrete surveillance and potential control mission. They operate under the assumption that if the target is observed, it must also be prepared for neutralization.
So we've completed the entire chain of evidence. We need to pull all of these independent threads together now. And the conclusion from the source material is stark. The probability of an artificial origin for ATLAs is estimated at 20 to 25%. And that range is scientifically defined as the Alarmzustand, the alarm state.
And it's crucial to remember that this high probability is not based on one single piece of ambiguous data. It is based on the cumulative effect of multiple statistically impossible and strategically rational anomalies all happening at once.
Let's review that foundational chain one last time, because this really is the synthesis of the source's conclusion.
Okay, first we had the statistical absurdity, the 0.2% ecliptic trajectory.
A path that defies the random distribution of natural debris, but is perfect for a purposeful grand tour of our solar system.
Second, the physics paradox, the clear, unambiguous signature of the retrograde burn, the antitail.
Which provides physical evidence of active gigawatt-range propulsion maneuvering directly against the gravitational pull of the sun.
Third, the chemical fingerprint, the water-poor, intensely blue, high carbon monoxide and cyan composition of its coma.
Which is chemically inconsistent with a comet, but perfectly consistent with an efficient nuclear thermal propulsion system that favors an abundant propellant like CO over heavy water.
And finally, the strategic decision-making, that perfect standoff distance of 1.8 AU.
Ensuring the object's own stealth because of our angular resolution limits, while at the same time maximizing its capacity for atmospheric and electronic reconnaissance of Earth.
The probability of all four of these independent, statistically improbable factors occurring naturally all at the same time in the same object is infinitesimally small.
That's what forces the cumulative estimation up into that 20–25% alarm range.
It's just too high a stack of intentional-looking coincidences to be dismissed as purely chance.
And let's reiterate that strategic point about its silence one last time. because it's so critical to the interpretation.
Yes.
The object's silence is not interpreted as proof that it's just a dumb rock.
No, it is viewed instead as a sign of the highest competence and tactical concealment. A strategic observer, as the analysis states, stays in the shadow. They do not transmit, because transmitting reveals your capability and, more importantly, your location.
If ATLAs were designed to be discovered, it would be shouting at us.
Exactly. Since it is silent, it reinforces the operational logic of a high-stakes, discrete surveillance mission that is employing that Matryoshka deployment strategy.
The object has done exactly what a competent intruder would do.
It's moved into a perfect observation orbit, it has collected its data, it has deployed its tactical units, and it has maintained absolute silence and stealth throughout the entire process.
Which brings us to our final thought for you, the listener. The spectacular flyby of ATLAs itself, that blue light moving away into the darkness of deep space, that might not have been the conclusion of an event.
It might actually be the unnoticed beginning of a new and potentially consequential phase in human history.
The ultimate question, which remains scientifically and frankly existentially open, is this. Did we merely observe an unprecedented astrophysical curiosity?
Or was that blue light the periscope of a submarine checking the surface right before the real operational component initiates its mission?
If the analysis of the Matryoshka strategy holds true, then the largest, most visible part of the mission, the interstellar trigger shift, is now successfully vanishing, creating the illusion that the event is over.
But the mission of the smaller, tactical scouts, however, has just begun. They're moving from standoff reconnaissance to infiltration.
So we have to synthesize this knowledge and, I think, acknowledge a new reality. Regardless of its ultimate nature, ATLAs forces us to admit that the possibility of intelligent engagement is now scientifically above the noise floor.
We can no longer dismiss the potential for advanced technological visitation as mere science fiction or speculation. The evidence demands serious scientific attention.
And this leads us to our final provocative thought, which is rooted entirely in the source material. If ATLAS was designed specifically to avoid identification, and if the main vehicle successfully disguised itself and then vanished back into deep space, what evidence of the smaller tactical scouts, those 5 to 15-meter drones optimized for stealth and maneuverability, should we, here on Earth, be monitoring our local environment for in the coming months to confirm that the mission is still active and ongoing?
The show is leaving, but the audience may have already arrived.
We leave you to ponder the blue shadow in the solar wind.